Okay, recording has begun. If you, as you're looking at this, give me some ideas. What are some things that you've done with this one, with the water cycle? I know we've already done the water cycle. Once did a walkthrough with an associate superintendent, and he said it feels like everybody's doing a review lesson on this. And it was interesting to talk to him about what it is that was happening, that we've already taught water cycle is an aspect of weather. Now we're looking at it as a physical science and how we're cycling through the phases of matter and how that's happening, improving that. So what are some things that you have done for that in the past that helped you to get kids to understand and be able to explain the process of the water cycle and its impact from the sun? No, we're just got Miss Campbell from Kimberly Park just came on. Welcome. Water cycle play. Everyone has a part to, and they make props to perform for other classes, and the repetition helps them. Okay. I've seen different things where they're writing stories also about the water cycle and where it's beginning, and it's the kind of like the life of a water droplet as it's going through, and they have to pick something other than a lake or the ocean to start in. So I had kids starting in mud puddles and starting in different places. So that kind of goes along with getting to the creative part of what you're doing. That's there too. My computer keeps telling me Miss Williams is typing like crazy, so I'm looking forward to reading this one. Using the cycle as an organizer, at each process identify the phase of matter change, giving the real life examples not in the water cycle, and also identifying the loss or gain of heat energy. Great connection there. The diary of a water molecule, water cycle scoot stations, and movement through the water cycle. Good. Some great ideas there. We'd like for you to go to the training page in Power School Learning or Haiku. And I want you to take about 4 minutes watching through. There's 2 videos about making it rain inside. And there are ways to model the process as they're going through the water cycle. The first one happens, and then we took a second one after about 20 minutes or so, and to see that what's happening to make it rain inside. I used to get my kids excited about telling them it was going to rain in the classroom at some point throughout the year, and I had this bright yellow slicker poncho that I would wear on the day that it was going to do it. So they thought I was a little bit nuts as they came in and they saw me looking like the Morton's or the either the Morton Salt guy or the fish sticks man with that on. So the kids were excited about what they were going to do and see that it was going to rain or precipitate in the classroom. So go to that page and watch those two videos. Making it rain inside, number one and number two. It'll take you about 4 minutes or so to watch those two. And when you come back, just give me an okay in the text box at everybody when you're finished watching those ones. So most of you are finished up here. Those of you that are having troubles, each of these videos are in YouTube by the titles that they have on them that are here. So they shouldn't be very hard to find there. I don't know why you're having issues with them unless there's a bandwidth issue in your location. That doesn't make sense either. So I'm sorry that that's happening. So what it was is that we've created a model of the water cycle that we have, and that model allows us to watch the evaporation happen, watching the condensation happening as it cools, as it gets to that upper atmosphere where it starts to cool, where we have the ice up there, and so you can see the condensation. So as that condensation starts to come together, the drops get heavy and fall. The second video, you get to see those drops that are just hanging there, waiting to drop as precipitation. So that's kind of where we were with that one. One of the things that we really like to see is kids doing a multitude of different activities that work with the water cycle. So the writing the stories with it, the drawing of it, the notebooking about it, the plays, the acting of it out, going along with a model that goes so they can see that those things actually happen. I think the multitude of ways to see it, I think, really is beneficial. Could you hear me? I just spoke a bunch. Hopefully, you can hear me now.
I could hear you, and then you went out for like 30 seconds.
No, I probably said nothing more than what you already knew. We just always look to having a multiple ways for kids to learn something, and so we look at giving them opportunities to play with models that are about the content. So exploring and modeling and to go along with the writing and the drawing and the plays. I hadn't thought of a play, so I really like that idea. Um, so I'm going to end up talking to Miss Faber about that one a little more, I think. But just giving them multiple ways to do that. And to me, a lot of the things that you're going to see in here today are things that are pretty simple and not expensive to do because we're giving 2-liter bottles, and some of you still have eco columns in your rooms that are dying off. So you don't even need to go get another 2-liter bottle. You just might need to clean out the ones that you have as you pour out the goods that were there. But it would really be it gives kids a chance to see the water cycle happening, the condensation coming together, why it precipitates with that droplets getting too heavy to stay up in the atmosphere any longer. I think has always been something that the kids get a kick out of because it's not something that they've thought about before. Anything to add to that one there, Mr. Potts? So it's not just me sitting here alone in the basement. I do have friends. So does anybody have anything else that they've done for? Yes, I have a dog who's decided to shake down here too. Excuse me. So does anybody else have any other activities that they do, a lab or a demonstration that goes with the water cycle? Anybody have done anything like that before? Ah, yes, Miss Williams. Olive Smith Farm did the baggies on the windows so that they could see the water cycle happening with those. I liked those ones too. The interesting thing about that one is you could see one side of the hallway had a lot of afternoon sunshine. The other side did not have as much of the afternoon sunshine. So that was interesting for me to see going from room to room. Miss Baker, yes, the lab could work using glass. I've seen it happen with a glass jar and using a plastic bag as the top to put the ice in. I've seen that happen. My reasoning for liking the 2-liter bottle is the curves that are on the bottom. That is the ice cup. I think that to me is the part where they can really see how those droplets are coming together, getting larger and heavier, so that when they fall, you can see why that happens. But yes, I think it can happen with that. The eco columns, I think I've always been impressed with the amount of kids who end up talking about seeing the vapor that's happening and the evaporation and the condensation that's inside of the eco columns as well. I think that I've always thought that was an interesting one, and some people are able to catch it and some people are not. So I'm grateful that that was there, because if you really stop and think about it, a lot of our topics do overlap with the energy transfer and what's happening in an ecosystem, and this one pulls back in the biotic and abiotic that we talked about in our ecosystem unit. So I think that's a good connection. The other thing that what this one does to me is that I like to have them drawing and labeling, and it's not that standard picture of the water cycle. It is a larger, it's of a different scale. So I like to see that part of it. And now I've just lost my buttons on my screen. I got to figure out where everything went. There we go. All right, so what we're going to do, if I can, I'm going to go back to our so I want to go back to the standard. We're going to do a little, we're going to read a little bit more of our next standard, or the next objective that's there. All right, so I've pulled back up the standard of the unpacked document. So now we're going to get into the second one, 5P 2.2. Compare the weight of an object to the sum of the weight of its parts before and after an interaction. And the unpacked part says 5P 2.2, students know that the weight of an object is equal to the weight of the sum of its parts. This is true in all closed systems. We talk debates about whether or not we should be talking about weight or mass. We talk mass in certain spots and weight in different spots. But state's telling us weight in this one, so we need to kind of watch ourselves with this and to teach our kids with weight for this, realizing that there is a bit of a misconception between weight and mass. But we have been communicating that with middle school so that they understand what it is, what they've been taught, so they can correct and to extend them to that as they go. Because if we start getting into mass, we could be creating a little bit of misconception, and also that puts us not teaching it to the standard, and then they get a question on weight and they might not understand it. So we want to make sure that we're teaching it the way the standard is written, thinking about science not just as this year's science stuff, but as a student's career of science, the whole story of science for your students is it starting in kindergarten or even pre-K and working its way up to high school and preparing them to go out into the real world after that. So we are going to look at it that way. How we're talking about weight. Yes, you're absolutely right. The weight and mass are different because of. So we start talking about mass. We're talking about the particles that we have that are in us and what that looks like. So I do think that there's the conversation can be had but for this we need to focus on what is the weight for what is there. Giving them some of that information, but just in our labs, our demonstrations, our activities we're going to focus on that weight piece for this, just to help them so that there's not as much confusion as they're moving on through the rest of fifth grade. So does anybody have questions about that piece for us while we're talking about the weight? It's Miss Faber. It's something that we have debated, and as Benika says to us all the time, the more we know, the better we do. The better we're going to do. So we start debating. There's a handful of things, and in the next objective, I'm probably going to ruffle some feathers on it because just by looking at things in the whole the length of this story of science that we talk about. There's pieces that we tend to get to, and I have done in the past, that I think we were extending beyond our standard, and it's going to create a misconception in some spots, and just because of the background knowledge that is needed. So that mass versus weight is one, and we're going to get to the next piece in the next one. I know there's going to be some issues with the interactions that we'll talk about there. Let me know where Miss Williams is.
You got 2D for my screen.
You were seeing your screen and my screen because I was presenting it. All right, so we read through 2.2, and I want to read through 2.3 before we go on as well, because the next couple videos we've kind of melded a little bit of the two together. So we're going to talk about the weight. In the next couple of them, we're going to talk about things, but we're going to do some describing as we go. So I want to talk a little bit about that. Our 5P 2.3 is to summarize. Our verb is to summarize that one. We need to summarize the original materials and the new materials formed to demonstrate that a change has occurred. So students know that by making qualitative and quantitative records, we're able to create before and after representations of materials and their properties, so that we can compare before and after versions of the materials. So as we're doing our demonstrations, as we're doing our explorations with students, we're going to have them notebooking, taking down qualitative and quantitative records of what they're seeing. So as we're talking about different pieces and putting them together, I want them to describe the properties. What is the color? What is the texture? What shapes do they have? Are they shiny? Are they dull? Are they solid? Are they liquid? Are they gas? Those qualities that we have, but also the quantitative. So we're going to measure some heights, some widths, some depths, some masses, some volumes, some weights. Not masses. I misspoke. Forgive me. So we're going to do a lot of those things as we are looking to compare the weights of them. So we're looking at the total is going to equal the sum of its parts. In its true closed systems, it's very difficult to have a true closed systems at all times, and we're going to you're going to see an example of that one in our video. So let me know if you have any questions on this one. So yeah, let's go into the next one. Next video we're going to look at is going to be that sum robot. There is a worksheet or a lab sheet that you can have to go with it. If you look at the page, it has an example of that. And this sheet is on the resources page in Haiku as it is. So we've got the recording sheet that you have an example for on here, as well as the video of that sum robot with Warren doing that one. So why don't you take that one? Think that one's not too long, but we go ahead and watch that and go ahead and give me an okay or I'm done when you get done watching that one as you look through it. It's going to be about 4 minutes. 4 minutes. I like the clever name of Some Robot. It's just me. Miss Williams, I want you to check with Miss Zash and see if we have one in the library, because I think you do, and if not, we'll have to check into that one. Yes, we'll just take some space in S-Mass.
What?
Third grade, take some space in S-Mass. Yeah, Warren just brought up a good point. As we look back at the third grade matter standards, they start talking about gases, and you love third grades talking about gas. You know the kind of conversations they'll have. But the third grade standard says that students know that air surrounds us, takes up space, and has mass. So they're pulling in mass for that one. So again, I'm not sure exactly why it is that we're doing it the way we are, but I want to make sure that they're having the best opportunities with what we have with this being here. Because they don't get into changing of gravity in third grade as they talk about the different planets either, I don't believe. So I'll need to check into that a little more. But let's stick with weight for this, just because I think that's the way the questions are going to be written for us. Maybe we can connect some dots at a point towards the end of the year as well. We generally have a couple weeks after testing where we can put some things together and get these kids really, really ready for sixth grade. So just thinking about that one. So that making that some robot. Do we have what other things have teachers done to get to this one? Looking at solids, we've got something we're going to talk a little bit about with liquids and some solids and adding them together. But is there anything else you've done? Trail mix, great one. I forgot about that one. Somebody was talking about that the other day. You're making me hungry, Ms. Williams. Luckily, I'm not too far away from a refrigerator. Trail mix is a good one. Salad. I've seen people making salads before too with different pieces. But again, you got a lot of weighing of different pieces that are there. Yeah, parts of a car. We've talked about instead of making a robot using the snap cubes, but getting into the STC kit for motion and design and making the car and weighing the car and taking the tires off and the axles off and that piece as well. So that's a great, I thought, as well. Yeah, weighing an apple, being a true closed system, the scales that we have, the digital ones, they get down to 100th of a gram. So as we do that one, you're going to see in the next one we talk about with some liquids, there can be some discrepancies with it because of how sensitive it is. But even the moisture that's left on the knife after cutting the apple could be a little bit of the reason why it's not exact. So that's something to think about too. I think cutting an apple is a great one because you're getting the big picture of what it is. And those chunks are going to equal out what is there. You're a smart one. So any other food things? I like food. Warren knows that. We've got too many stories of the two of us with food. I'm glad Mr. Seward's there too. The banana, no juice. Okay. The texts are coming in good. I like that. The fruit's great. I'm thinking pizza right now because I'm getting more and more hungry. The different pieces that are there. You can make your nachos and put them in your solar cooker and take them outside on a sunny day and make them that way. We're going back and doing some spiral review. All right, let's leave food for a minute here. Um, what I want for us to do next is our next one that we have is um, check my page.
Um,
And let's compare the weight of the sum of its parts. It's a little bit of a longer one. This was about 8 minutes, I believe it is, but it's going to be talking. But this was connected with the. Um, show my screen here again. One of the reasons we do this one is to um, connect with the formative assessment probe book, the Lemonade probe, and the Lemonade probe gets into kind of looking at the dissolving of a powder dissolving into a liquid. So we're kind of leading into that one. So the lemonade probe is one. I always like to do the lemonade probe as my pre-assessment, see what they think about it. It's always fun to see what they think, and then going ahead and running through and making some, and what we use is some fruit punch to make this. And so go ahead and watch through this one. Excuse my brain lapse on some mental math as I start going through this towards the end. We talked about how I probably was going to flub that one up, but it ended up turning out all right. But so go ahead and watch through as best you can. If you need to, YouTube has these videos that are on there. Go ahead and search my name, and we have a channel that's mine, and it has all of our videos that are on there. But finding compare the weight of the sum of its parts should be on there. Actually, if you hit the share button up here, it should give you that link and take you to YouTube. If it's an issue with PowerSchool Learning, that should help. If it's not, then I'm not sure exactly what's going on. For that, I apologize. So go ahead and watch the compare the weight of the sum of its parts, and then we'll come on back and talk about what's going on there. But remember, we're going to focus a lot on the explore model and demonstrate with our kids, and the notebooking into writing down and going through and giving them opportunities to notebook, to do lots of activities and own the learning by writing about it, drawing it, and those kinds of things. So go ahead and watch those videos, and again, give us a text chat when you get it all done. Just compare the weight, and we'll talk about the next piece. Glad I did get trail mix. That's the glorious thing about this. I learned something interesting too, is that the webcam on these fancy laptops that the district gives us, it pans to find your face. So if I move, it's going to move too. I thought that was interesting. Yeah, I'm easily amused. Creepy. Mm-hmm. I think it's got an attraction thing here. I don't know. Okay, so with that one, we took a solid and a liquid, put it together. They saw an interaction, something that changed, something that happened, and it went from a clear liquid to a red liquid. They saw the mass change. Wait, excuse me. I understand the frustration with that one. We also got a chance to see something that dissolves, and we don't see anymore for the most part. There's a little bit left over there. You can put too much of something in there, and the liquid will not hold any more of it. But for the most part, that gives us a chance to see something that is that whole dissolving thing. It looks like it just disappears. So the mass or weight should not change, but the fact is that it does. So I think it's great to have kids see that. And just a pack of lemonade or a pack of fruit punch or Kool-Aid is something it's an easy grab for you to have. What's crazy is that I found that in the warehouse. It was hard as a rock, but that was just a bag we found in there. So it does give us the opportunity to look at, see what happens quantitatively and qualitatively as we're adding solids and liquids together. More experiences for kids to give them things to connect to and to remember. They remember a lot of the things that you do, a lot of the things that are done with their hands, a lot of things they're experiencing that they didn't expect. So I think it's a great opportunity to have. Did anybody do anything with any liquids or adding solids and liquids together or anything like that in their classroom? What are some examples you've used to do 4 or 5P to in your classrooms? Have you done anything with liquids and solids, adding them together and to check the mass, or has it always been solids that you've done, or always just liquids, or have you looked at adding more than one type of mass or type of matter? Excuse me, that word's me stuck in my head. Mm-hmm. Some frantic typing happening around here. Great question. So with that, let's go ahead and talk about our next standard here a little bit more in depth, and we'll kind of talk about that one. So I'm going to go back to our desktop sharing here, and we are going to it's hiding what I want to get to here. There we go. All right, so in our third objective, it says Summarize the properties of original materials and the new materials formed to demonstrate that a change has occurred. Doesn't give us any more ideas about what those changes are and how to explain them. Students know that making qualitative and quantitative data records, we are able to create before and after representations of materials and their properties. So we can compare the before and after versions of themselves, of the materials. So this was a debate that's happened over the last couple of years is where does it tell me physical change? Where does it tell me chemical change anywhere in our standards? Physical properties through K5 are mentioned in a couple different locations, but we never get to the chemical piece. And kind of the reason for that is to get to a chemical change, we have to understand what is chemically there and what is chemically changing. And with that comes an understanding of chemistry and understanding, being able to balance that equation as to what we have. So getting to that is this a chemical change? Our standard doesn't ask for us to identify if anything is a physical or a chemical. It's asking for us just to describe or summarize what it is before and what it is after. So we're getting to that point of, well, is it different? Is it the same? What does it look like with our observable qualitative and quantitative observations? Has the mass changed? Has the weight changed? Does it change state of matter? Have we created something new? So with it being said, technically, I think if we were to say we make the fruit punch, we make the Kool-Aid, and we evaporate all the water out of it, we now have water vapor and Kool-Aid, so we're technically are back to the same materials that we started with. So I don't think it would be a chemical change. However, is our mass the same? Is our weight the same? I'm going to kick myself. I'm going to keep saying that. Warren's going to start kicking me every time I say it. So we have to kind of stay away from the chemical piece. 7th grade, they're going to get into chemistry. They're going to start balancing equations and looking at what do we have before and after. So the evaporation piece, it's going to get down to creating a precipitate, which is, again, beyond what it is that we need to be doing for 5th grade. So are we needing to identify if it's chemical or physical? No. We're needing to be able to summarize qualitatively and quantitatively what we saw before and what we saw after. So with our Kool-Aid, we saw a clear liquid. We saw a red solid. We had an interaction. We added the two together. We shook them up, and we had at the end of it a red liquid. We had a mass that was, or a weight that was very similar. And we're trying to, just kind of describing what that looks like and what it is. They're going to get to where you're getting to with, is it a chemical or physical or chemical change? But they're going to get to, my chemical change is, I started with H2O and added sodium bicarbonate together, and I'm going to come out of there with a carbon dioxide and a hydrogen that's coming off of it, if that makes sense. We're going to have that chemical equation that we have there. Solutions and mixtures. I don't see that in our standard either. So we can talk about putting things together, but what is a true solution, and how is that part of what it is? You look up 4th grade for solutions and mixtures, please. This is a piece that you know, I was on board with going to chemical and physical, because to me the definitions are almost there as to what we're looking at, but it is a new material. So in our last video that we're going to do, and I'm going to have you guys go to that one here in a minute, and then we'll come back and we'll kind of hash through a little bit of this one. But the last one is a balloon in a bottle. In Miss Williams, if I'd have been teaching the last 2 years, I probably would have been doing it too. So I can't fault anybody on that one. But it's just kind of the conversation of as we talk to other people and we really start digging into what it is that 7th grade, we start doing things that in 5th grade that are really 7th grade standards. So we need to kind of focus on what it is that we need to teach and let them do what they need to teach, and we'll focus on our stuff and do better with our stuff. So I think that's kind of where we are. Ms. Bush, I'm interested about that, your solutions and mixtures there for 4th. We'll check in on that one. All right, so let's go one more video. We're going to do balloon in a bottle. and then we'll pull it in. We'll look at that one. This one's fairly short, I think, and we'll go there, watch that one, come back. We'll talk a little bit about how we can wrap this up, and then we'll talk about what is going to be the expectation for you guys to get credit for this thing. We're going to do something just a little bit different. So we'll talk about that. So let's go look at balloon in a bottle. There is a lesson plan and activity that we get that's paperwork that's in the resources page on the regular resources for this one is there. So you'll have the right for that one. This one's about 5 minutes, it looks like. So go ahead and watch this one, and then we'll wrap this thing up and send everybody on their merry way all the way home, even if you're our home. So go ahead and watch it, and let me know in the text chat box when you're ready. So you're saying you want to hear me. So if we look at what those are, and they're going to debate it, whether or not it's a new substance or not, that's okay. We can say that because it looks new. But what are our particles that we saw in there? We had a liquid. We put a liquid and a solid together, and we got another liquid. Was there anything new that was created? So as we put the vinegar and the baking soda together, we saw that something new was created. So we have a new substance. We put a solid and a liquid together, and we got a gas. So with that, my liquid is different than it was before. My solid has disappeared and dissolved, and I've got a gas that has formed. So with that, we're going to say we had a solid and a liquid, and I created a gas. So I do have a new substance that's there. But I don't need to get into what are the chemical properties of what I had, getting into that acetic acid and adding the sodium bicarbonate and getting out of it carbon dioxide, and I don't know what the rest of it is. And we don't need to worry about that because we don't need to get into the pieces of the chemistry that's there. Ah, you're amazing. So I think with some of the times with some things, people talk about, well, this is a chemical change because this, and there can be a debate on that because what new thing is being made? What new properties do we have? And there's things when people will say things to me, this is a chemical change, and I'm not sure it is, and I have questions about whether it is, and I have to go ask somebody else. But the glory of what we have in fifth grade is we don't need to decide that. We just need to look at it and say, do we have something new? If I take a piece of paper and measure it and burn it, and now I have ash, do I have a new substance that is there? I just released a bunch of gas as they burned, and that gas went away in the smoke. But I still now have ash. My ash has less mass, less weight than it had when it was regular paper. So we can see some of that, but we don't need to get into the biggest piece of it, the biggest of the debate of whether it's chemical or physical. We just need to get into what do we have to start with, and what does it look like, and what is the data saying, the qualitative and quantitative data say about our beginning and our end. Say it.
And so, hey everybody. And so I think it's also important to discuss those observations being made during the process. Yes, it's talking about what you started off with, what you end with, but we need to collect those quantitative and qualitative measures during it. And so there, for instance, if you want to pull up a clip, there's tons of clips of people burning paper, and you can that way to be safe, because we do want you to be safe in the classroom with our students in our district. So a safe way to do that would be to pull up a YouTube clip of burning paper and describe what's happening, what's the interaction. We're providing thermal energy with the paper, and the paper that was white and had the dimensions of this length and by this width now is burning, and I've created an interaction between thermal energy and paper, which is a solid, and having those kind of discussions with your students. And them recording, because that is, even though we haven't provided a lot of evidence or showing you how to do that with your journals, student journaling is something I hope that you know that we're big advocates for and want to see students doing.
So I hope this is a little bit clearer for where things are. I think a big piece of what we do as we're teaching is we forget to teach to what that verb is asking for us to do. I know when I started with this, I started looking at the heat transfer, and it was always, we need to identify what type of heat transfer I have here. This is radiation, this is convection, this is conduction. But the fact is, my standard says I need to explain what is happening there. So this is radiation because the electromagnetic waves are coming from the sun. So getting to the explanation as to what that is really is the point of what we're getting to. So with this one, it is the summarizing the before and after, getting that data in there, getting them really looking at what those pieces are, that critical thinking piece for our students. As they get into sixth grade, they're going to get more and more data, and then the further they go, the better we get them looking at the numbers, looking at what the physical properties that we can see and measure are, the better they're going to be able to describe later on as they get into the chemical piece as well. So I hope that's beneficial. We're open to any questions that you may have. I think we've gotten through a lot of stuff, and I'm hopeful that this has been beneficial. But I'll take some questions that we have. We've had some great ones coming through, and I appreciate it. Yeah. It matters, kid. I don't know. I'm not familiar with it. Do some of the lessons in there, plaster and balloons. So yeah, I think there's some merit to some of that. Mystery bags. I'm curious to know what you've got in your mystery bags, and if it's talking about the properties of something that's in there, I think that's got some serious good ideas to it. Okay. Using senses, yes, definitely. But I want to make sure that we get them to some of the quantitatives as well. So we're getting to some of the measurement of some of our things and getting to some of those interactions. So yeah, a lot of what's going on in K5 this quarter is kindergarten starting working with solids and the properties of solids. Second grade gets into the properties of liquids. Third grade it includes the properties of gases and connecting what are solids, liquids, and gases, and that they all take up space and have mass. And fourth grade gets to the properties of solids in rocks and minerals. So they get into actually the applying of some of those different physical properties for that one. And then we're getting into some of the things that are making changes and those interactions that are there. So I think that's a good connection to be. With ice and warm water lab, did you measure the heat of the water after it started to rain? I'm thinking heat transfer connections. I didn't because the water in the bottom was still warm and the ice water was still cold. So I couldn't get just a measurement of what the drops were on the side. But I think that would be fun to see, but I'm not sure I can get that one. It's a good question, Ms. Baker. So to my knowledge, I don't think that the words physical and chemical changes are on there, because if they are, they're going to be the, what do they call those questions that don't count? Field test questions. Field test questions are ones that they don't count, and sometimes they put things in there just to see what it is that teachers are teaching, and that they don't count. So if you see them, it's very possible. I think there's 15 field test questions on an EOG, so something to think about too. I'll find out on Tuesday. We'll talk about Tuesday as to what your we'll check it out. Ms. Williams, are you testing on Tuesday, Ms. Williams? Okay. I'll be there in the afternoon, Wednesday. Okay. So there's not any other questions or things to do here. Let's talk a little bit about getting you some credit for this. So one of the things we're going to ask for you to do we've been asked to start taking some pieces and looking at some artifacts as to what's happening with our trainings. So to get credit, we're going to ask for you to send us a lesson plan. You do lesson plans every week. Send us just the week of what it is. Say, look at Tuesday, we're going to do that some robot. Send us 2 pictures of students exploring, model, or demonstrating something from the standards. And that's what we want to see. Is we want to see what the lessons are, how the kids are doing it. We'd love to see some of the notebooking that they're doing as well. But sending us onto those, and please feel free to tweet those as well. We're going to ask for emails of them for us so that we can make records and have them for when they ask us for what our artifacts were for this training. But also, but the tweets, we're using the hashtag EXP model demo for our Explorer model demonstrations. And we are the district is WSFCS _science. The guy next to me here, he is Hot Pot Science on the Twitter, and I am Sci Coach OV. So add us in there. We love to see what's happening in schools, and we're getting a lot more happening out there, and people are talking about it. And so we're really excited when we see those. So thank you for all of that. With that pieces in here, we're going to leave this page up for a while. We're going to ask for us to have by the middle of February, so the end of our unit, we're going to leave this training open till then for you to give us our lesson plan and the 2 pictures of students exploring, modeling, and demonstrating your standards before we close out this unit. So please stick with us, help us out as with this one, and give us some of the things that we have. We're starting this. This is by the next. This is in the third quarter. So we're going to be asking for this by the middle of February is when when this unit ends. So we're just going to say within this unit. And the lesson plan as a school team. Yes, since I've got your whole team here tonight on us virtually here. So yeah, 1 lesson plan, and I'd like to have 2 pictures from each class though, so we can see what's happening in each one of them. That's coming from Smith Farm. I don't know if we have anybody else. You all right with the same thing coming from Kimberly Park? One lesson plan from the 2 of them, but 2 pictures from each of you from Kimberly Park as well. So that'd be great. Oh yes, we don't need to just worry about starting this until after this into the third quarter. So I believe it starts the 22nd, I think, is the first day of the quarter. Yep, following the district blueprint. Thank you. So thank you all for being here tonight. I'm taking down who's been here by the chat box. We're gonna. Warren's playing games on me over here. We're going to. 2 opposing Steves on the screen. That's because I've got this here and I'm still presenting. Is that what it is?
I don't know.
So I'm not sure where I was going to go with that. Deadline. Let's say February 15th. Type in February 15th for Ms. Campbell, please. We actually joked about this as doing this here. We're going to do this as a Wayne's World theme. So with the 2 of us down in the basement, so we're going to start jamming out and party on. If you have any questions, please shoot us emails, ask us questions. If you want to, we'd love to see you on the Twitter, but I know that's not for everybody. So thank you for your time tonight. Said I try to get you out at 5:30. We're a couple minutes after that, so I apologize. But have a good night. You take up space. You have mass, so you matter. That's our sign off for tonight. So thank you all, and have a good evening. Have safe travels home. And we're going to stop recording. Did that. How do I stop recording? Here, maybe?